The constant of variation is the number k in equations of the form y equals kx. So here we can see that in this example, a car is driving at a constant rate of 1 hour and 30 minutes. So the constant of variation would be an hour and 30 minutes because each time the car is driving an hour and 30 minutes more. Okay, so let's look at another example. So there are two types of variations we are going to be looking at, direct variation and inverse variation. So let's look at an example of direct variation. So we write direct variation as y equals kx. So in this table we have 6 and 12, 7 and 14, and 8 and 16. So now y increases, as we can see, 6, 7, and 8. And we can also see that y increases as well, so 12, 14, and 16. So we are finding the constant of variation in the table above. So since we know that y minus kx, we can say that k equals y over x, or k equals 12 divided by 6. And therefore, 12 divided by 6 equals k, or k equals 2. 14 divided by 7 equals k, or k equals 2. And 16 divided by 8 equals k, or k equals 2. So in this example, direct variation, we see that y equals 2x because we have to multiply x by 2 to get y. So that's an example of direct variation. Now let's look at inverse variation. Okay, so this is an example of inverse variation. Hooke's law states that the displacement d that a spring is stretched by a hanging object varies directly as the mass m of the object. If the distance is 12 centimeters when the mass is 4 kilograms, what is the distance when the mass is 5 kilograms? So first we have to write out our equation, and that is d equals km, because inverse variation is written as x times y equals k. So in this example, we can see that d equals 12 centimeters and m equals 4 kilograms. So we write that as d equals km, or 12 equals k times 4, because 4 times 3 is 12. So what we have to do is divide by 4 on both sides, and we get 3 equals k. Then we have to do 3 times 5, and that equals 15. So d equals 15 centimeters. So our inverse variation, by using the inverse variation, we get d equals 15 centimeters. So now you've seen both examples of constant of variations.